Welcome to stage 2. This is where things get real. Up to now, we've been talking about single computers. From here on, we're talking about how they talk to each other. In this lesson, we'll cover 4 pieces: what a network actually is, the 5 sizes from PAN to the internet, wired versus wireless trade-offs, and the boxes you'll find in any network closet: hubs, switches, routers, and access points. By the end of stage 2, you'll be able to trace a packet from your phone to Google and back, naming every step along the way. So let's start with the simplest possible definition. A network is just 2 or more devices connected by some medium: a cable, a radio signal, light through fiber, and speaking a shared protocol so they can actually understand each other. That's it. Your phone talking to your earbuds over Bluetooth. Network. Your laptop pulling a video from an AWS data center halfway across the world. Also a network. Same 3 ingredients: devices, medium, protocol, the just wildly different scale. And remember that recipe, because everything else in this stage builds on it. And that recipe scales, literally. Networks come in 5 standard sizes, named by their range. At the small end, a PAN, or personal area network, covers about 10 meters. Think your phone and your earbuds. A LAN, local area network, fills a home or office over Ethernet and Wi-Fi. A MAN spans a city. A WAN stretches across regions or continents. And the internet is just the giant network of all those networks stitched together. Memorize these 5. They show up on every certification and every network diagram you'll ever read. Here's the key insight. Those 5 sizes aren't separate categories. They nest. Your earbuds talking to your phone form a PAN, which sits inside your home LAN, which connects through your city's MAN, which rides on a regional WAN, which plugs into the internet. It's the same root folder file hierarchy you saw back in stage 1, just with networks instead of directories. Bigger always contains smaller. Now, piece 3. How do those nested networks actually move data? 2 options dominate: Ethernet cables and Wi-Fi radio waves. Wired wins on speed, latency, reliability, and security. Wireless wins on mobility and cost. That's why the desktop at the help desk is plugged in, but the laptop you hand a user roams on Wi-Fi. Same network, different jobs. Piece 4. The actual boxes you'll meet in any network closet. A hub is the dumb ancestor. It shouts every packet at every port. So if you spot one, replace it with a switch. A switch is smart. It learns which device sits on which port by MAC address and delivers traffic only where it belongs. A router goes one level up. It bridges different networks using IP addresses to move traffic between your LAN, your ISP, and the wider internet. And the access point? That's the bridge from wired LAN to Wi-Fi. No AP, no wireless. Now let's pressure test all of it with 5 real scenarios. Phone to AirPods at the gym. That's a PAN running on Bluetooth. 80 desktops and Wi-Fi in one office. Classic LAN. Ethernet plus Wi-Fi 6. A university campus stitched together by fiber across 5 buildings is a MAN. A bank linking 12 city branches privately is a WAN, usually MPLS or leased lines. And loading Dargslan.com from your laptop. That's the internet. TCP/IP writing across every network in between. Before we go deeper, lock in your vocabulary. These 12 terms are the foundation for every networking lesson ahead, and they'll show up on tickets, specs, and quizzes constantly. You've already met the 4 sizes: PAN, LAN, MAN, WAN. Add the 2 media: Ethernet for wired, Wi-Fi for wireless. Then the hardware. Hub is the dumb legacy repeater. Switch is the smart LAN traffic cop using MAC addresses. Router joins entire networks using IP. An AP bridges wired to Wi-Fi. A bridge merges 2 LANs, and topology is just the shape: star, mesh, bus, or ring. Memorize these 12. Everything else builds on top. Now, before we close out, let's clear up the 5 myths that trip up almost every beginner. First, Wi-Fi is not the network. It's just the wireless on-ramp. Plug in an Ethernet cable and you're on the same network without it. Second, more bars means stronger signal to your access point, not faster internet. Your ISP still sets the ceiling. Third, Ethernet usually beats Wi-Fi, but a modern Wi-Fi 6 connection will smoke an old 100 megabit jack, so check the specs. Fourth, a LAN doesn't need the internet. A printer and a few PCs on a switch is a working network. And fifth, a VPN encrypts and reroutes your traffic, which almost always makes it slower. Use it for privacy, never for speed. And that's lesson 8 in the bag. 5 network sizes, 4 key boxes to remember. PAN nests inside LAN, inside MAN, inside WAN. Wired is stable and fast. Wi-Fi is mobile and easy. And switch, router, and access point are 3 different jobs. Next up, lesson 9. IPv4, the 4-octet address every IT pro reads daily, plus public versus private, and a first taste of subnetting. Stage 2 rolls on. I'll see you there.